Okay, I've made you wait long enough. Thank you so much for your patience. We're going to go ahead and get started now. So thanks again for joining this Kiuwan webinar, and today we're going to be discussing how you can secure your APIs and look at some of the API attacks that have happened over the past year and sort of examine how SAST plays into that, as well as some of the threats that might arise to your organization from API security risks. So applications are under attack from all sides, and for businesses across the globe, it's essential to stay up to date on the latest exploits, common vulnerability risks, and benchmark security within your organization. For many organizations, the OWASP project, I guess you could say, the Open Web Application Security Project, is that benchmark. They're a trusted nonprofit organization that regularly publishes software security analysis, offering a yearly roundup of the top web application vulnerabilities. And from 2019, they started releasing an API security vulnerability list as well. And this edition represents the trend that we're all seeing of growing threats in the API security space. As the value of APIs increase for your business and they become more integral to the way that you operate, it's critical to gain a deeper understanding of the potential risks and the steps that we can take to mitigate those risks as it pertains to APIs. So during today's event, we're going to get stuck into the challenges and risks that development teams face when leveraging APIs and ensure that you can get optimal performance out of your application and the way that you use APIs as well. So without further ado, here's the agenda for today's event. So we're going to start by looking at why API security matters. We're then going to examine the top API security breaches of 2021. We're then going to look at how you can use SAST to secure your APIs, and then specifically how Kiuwan can help. And then we're going to finish by taking any questions that you might have and directing you to additional resources that you can access from Kiuwan. So to kick things off, why API security matters. Today and for the foreseeable future, most computer and mobile phones users interact with the internet via an API system. This usually takes place on mobile apps, software as a service programs, web applications, online banking, online shopping, and so on. Essentially every single facet of your life. From the standpoint of sheer convenience, it's hard to overstate how much APIs have transformed the process of web browsing and maximize the extent to which regular internet users can get the best possible web experience. And I think we all know this to be true. Convenience, front-end simplicity, and user-friendly interfaces all make APIs one of the most prominent systems in everyday internet usage, web development, and innovation. In software supply chains, APIs have made it significantly easier for developers to create web and mobile applications that are both user-facing and user-friendly. It goes without saying that such user-facing app development is increasingly essential for the development of web and mobile apps in general, and thus for the expansion of internet commerce, entertainment, and other types of web usage. Unfortunately, however, this widespread usage has a significant downside. While the use of APIs has greatly expanded and improved most people's internet usage, it also leaves them vulnerable to critical security failures. The very nature of an API system involves the transfer and exposure of extensive quantities of data through third-party code. Much of this is highly sensitive and personal data, such as personally identifiable information, and due to the high quantity of such sensitive PII, APIs have unfortunately become a target for ill-intentioned actors around the world. An attack on an API may result in a user having their personal information, including financial data and legal identification information, stolen by malicious software or hackers. Though APIs are distinct from user interfaces, individual users may still suffer from critical data breaches if APIs are not properly secured. The expansion of APIs in everyday web usage has also expanded the risk of data breaches and malicious attacks against an individual. And not only that, but ongoing security threats against APIs will compromise and hinder future API development. And given the significance of APIs, such a hindrance to innovation and development would have widespread negative consequences for the overall usage of applications and the internet going forward. Thus, API security is an essential aspect of any API development and usage. This analysis will highlight many of the specific security threats to APIs in the current internet landscape, their consequences on web usage and online business operations, and possible solutions. In this context, the term API will specifically refer to web or application APIs that specifically interface two or more elements via the internet. And so when we look at the emerging trends in API security, we see that there are such a broad array of risks. And the OWASP Foundation has recently enumerated this list, and broken down. They are broken object level authorization, broken user authentication, excessive data exposure, lack of resources and rate limiting, broken function level authorization, mass assignment, security misconfiguration, injection attacks of multiple varieties, improper asset management, insufficient logging and monitoring. And that's a pretty broad list, and they represent some of the biggest attacks that happened over 2021, 2020, and 2019 as well. And so when we look at that, we can see that API security risks are really growing in the way that they can impact businesses. These risks and these vulnerabilities that we've outlined before can have significant downstream impacts. They allow hackers to get access to user data. They allow bad actors to gain access to your systems and then leverage them for additional attacks or gain insight into the operations of your applications. They can, essentially use your web portals to commit additional fraud. So all of these impacts are very significant. And as we mentioned, they're only continuing to grow in commonality. And there was just simply no shortage of API-related security incidents in 2021. In fact, Gartner's strategic planning assumption built in the increased risk of API abuses, predicting that they will become the most frequent attack vector and leading to data breaches for enterprise web applications across the globe. Gartner was almost correct, but not all the way. They perhaps underestimated the larger spectrum of potential impacts that exceeds just data breaches. So let's dive deeper and look at some of the more significant attacks that happened throughout 2021 and what that means for your business. Well, let's start with the most controversial one first, the Parler attack. This involved broken authentication and broken level authorization. And of course, it's embroiled in controversy due to the political nature of the events, and the storming of Capitol Hill actually resulted in the social media platform Parler becoming a central resource to learn about, sort of everything that happened, the planning, organization, and those involved in the event. And so in response to the event, a lot of digital activists siphoned and scraped as much data as possible from the platform, leveraging the platform's APIs prior to them being fully shut down. And this led users to experience a high level of privacy erosion with data and their activity leaked, effectively doxing thousands of users and also destroying the business. And obviously, in some cases, this can make sense when people are under criminal consideration. Getting access to their data might be important, but obviously we should always be concerned when applications are just leaking a variety of data without any limitations, because that can be used by anyone for any number of things. And so one aspect of the situation that was not heavily coveted due to the other unprecedented activities was the lack of security that was actually provided by the application and the associated API. The application exhibited a plethora of flaws, to be frank, including broken user authentication and broken object authorization on public APIs. They relied on user controllable parameters to control data visibility, used predictable sequential identifiers for most of their content, failed to scrub content metadata and geotags, and didn't use multi-factor authentication. It's easy to dismiss the events as a result of poor coding practices or unpredictable large-scale events that encourage action from activists or bad actors, and both of those are true. But there are some additional critical considerations in this regard. Organizations have to always ensure that their mobile application code is secure and meets expectations as well as existing security, industry, and regulatory standards. And it's essential to understand that applications are gateways to more valuable assets like APIs that power the business functionality and ultimately control end user data. The complexity of distributed architecture makes strong access control difficult to accomplish in practice. Authentication and authorization are critically important for all system designs. They have to be the priority. And organizations as such have to analyze the behaviors of their users within authenticated and authorized sessions to ensure that there are no malicious API calls and thus continuous visibility into security risk and the ability to closely monitor API consumption, as well as how the API is architected, is critical to data security strategy and is the primary reason why, in this case, Parler as an organization put customer data at risk and suffered consequences as a result. Moving on from that, let's look at another one of the most significant attacks that happened, which was the Microsoft Exchange server. This happened in March of 2021 and involved a server-side request forgery. So Microsoft discovered and disclosed an attack that was coordinated by a Chinese state-sponsored hacking group, which targeted Microsoft's Exchange server deployments in March of 2021. The initial attack vector was via a server-side request, forgery vulnerability, within the proxying front-end component of Exchange. This particular vulnerability allowed attackers to send arbitrary HTTP requests and authenticate as the Exchange server. Once attackers had access, they could exercise a more complex attack chain to gain access to the operating system itself, execute code remotely, and then attack other elements within an organization's network. The entire chain was made available by a set of 4 vulnerabilities, allowing injection of commands into a web request, privilege escalation, maintain persistence by planting a web shell, and then attacking other systems on the network. This was a significant attack on such a large organization that has ties to all industries. In order to respond, Microsoft had to quickly try and contain the damage, bringing in a number of tools and scripts to aid Exchange admins in determining if their infrastructure was vulnerable and thus mitigate the initial attack vector as much as possible. This additional containment effort was likely very pricey for Microsoft. With such a wide consumer base, the cost of remediating and preventing future issues is extremely heavy. For other organizations, this will be prohibitively expensive. For companies like Microsoft, it's essentially a drop in the bucket. For them, this is an operating cost that is easy to manage. But regardless of this, we have to recognize the risk. And oftentimes for smaller businesses, it's much more important to be proactive because the cost of being reactive is 3 to 4 times more expensive. And oftentimes that can derail the profitability of an organization entirely. The downstream impacts of this incident were substantial and resulted in a number of government notifications and advisories. Many organizations leverage Microsoft Office 365 within their SAST tools, and this collection of moving parts creates a deep attack vector. And it's a high-level example of the risks embedded in APIs, especially the largest and most widely used. Moving on to something that specifically impacted end users, the Experian attack of April 2021. And this, again, involved server-side request forgery. So this was discovered by security researchers that found this API flaw while working with a web lending application. This application called an API that was hosted by Experian, which was designed to assess an individual's creditworthiness during a credit inquiry. To be clear, this was an API created and leveraged by Experian with the relationship to this web lending application. So third-party websites would call the API to validate user-provided personal identifiable information. The Experian API used minimal information to identify and authenticate an API caller, and in return would serve the personal data in response to the call. And obviously, we can immediately see that there's a bit of a gap there that could create issues. The credit information returned by the API included FICO scores, risk factors, credit history, credit accounts, balance to credit, and any information that dictates an individual's creditworthiness, along with other associated personal identifiable information such as addresses, places of work and things like that. And so obviously it's important to keep all of those things secure and protected. And the required authentication material can be gathered through an internet search of public repositories or by purchasing or repurposing data. So, in this scenario, a hacker could have purchased a list of addresses, names, workplaces that were correlated to individuals, then use that data en masse to call the API and get the returned, and in return get the FICO scores and risk factors and credit worthiness. And that would allow them to have all of that information about one individual that they could then repackage on and sell or use to do something else equally nefarious. So the API actually had several vulnerabilities, broken authentication, since the API required minimal authentication material to get the response call with all of the PII. Security misconfiguration because the API did not properly validate identifiers. Excessive data exposure, since the API provided sensitive data. A lack of resources and rate limiting, since the script could be repurposed to enumerate other customer data. So the API needed to be architected in a way that data could be easily accessed by third-party lenders, and that would allow it to be leveraged during lending applications. Obviously, the key focus for the user experience side of things is to make that lending application as quick as possible. So you apply for the loan, and within 30 seconds to a minute, you get a response that's checked all of that information. Well, obviously that's difficult to do if we have several layers of security that might be, slowing down that process. And so, the common design dilemma here is that, we don't want to have too much authentication that could slow things down, but we also need to protect the user data at the end of the day. And so with this in mind, a traditional security approach just doesn't work. And it's essential for organizations in this regard to improve the structure of the API with security at the focus, and then add it and then leverage it within their application in a way that keeps that data safe and also allows them to obviously function effectively and as efficiently as possible. So going forward from the Experian breach, we'll look at the LinkedIn breach now. Obviously, this differs in some ways because we don't have something that is as pernicious as personal identifiable information in the same way. A lot of the information that would be available on LinkedIn is less, less relevant from an exposure standpoint, and more just we don't want personal data to be leaked in general. So the LinkedIn attack happened in June of 2021, and this was centered around broken user authentication. And we've discussed so far, many high-level organizations that have a wide user base, and this is just really no different. LinkedIn is a Microsoft service, as you might know, and they were embroiled in 2 separate incidents within the first 6 months of 2021. A large repository of private data had been posted for sale on an underground marketplace. The dataset contained information on roughly 700 million users, which was essentially the entire user base at the time. And while Microsoft maintained that this data was publicly viewable and did not constitute a data breach, the leaked dataset included a host of personal data, profile names, LinkedIn IDs, profile URLs, gender, email addresses, phone numbers, geolocation, experience, and addresses. And the complete dataset topped 180 gigabytes. And again, as we mentioned, while a lot of this data was public, in that profile names are typically public, along with any experience that you publicly list on your LinkedIn, the completion of the dataset and matches to email addresses and home addresses created a huge searchable database that could effectively be leveraged by hackers looking to target attacks through phishing, social engineering, ransomware, etc. And compiled datasets like this can also be used for credential stuffing and brute force attacks to gain additional value from this attack. And so obviously this attack more represents an entry point to create further attacks in different directions. And while this incident was quickly dismissed, it is a good vector to understand the state of privacy. This wide dataset can give particular value to hackers, and scraping via APIs is only becoming easier. So the quicker that hackers can access private information, the quicker they can launch further attacks or sell your data downstream, both of which are obviously bad. And with that said, APIs are hugely valuable, but with value also comes risk. So let's dive deeper and learn how SAST can specifically remediate that risk. One thing that is blatantly clear from the aforementioned attacks is that security by obscurity is simply not enough. Organizations can't hide API keys in an application package without exposing user data to direct risk under those with the ability to see inside of your application. Experts consider it akin to locking the door of your house, but leaving the key under the doormat and then forgetting that it was there. Application developers have to anticipate that sensitive API keys and tokens will be exposed during an application's lifecycle, and thus need to have robust, repeatable mechanisms in place for revoking and recycling exposed credentials. In addition, sensitive credentials should never be committed into version control systems. But these steps are not standalone security measures. It is of essential importance that organizations add security processes to mitigate the risk. The first step is to test the security within your APIs to identify 2 things. To ensure that the API designed works as it was designed to function. Obviously, that's critical. And then to ensure that the API cannot be used to do anything outside of the core function. One crucial element of this is ensuring that there are no vulnerabilities within the composition of the API. As mentioned before, the existing attacks all occurred because of the nascent vulnerabilities in the API configuration of the deployed applications. Removing these vulnerabilities is a critical first step in reducing the risk and avoiding potential attacks. And the only way for developers to ensure that each API is comprehensively analyzed is to automate the generation and running of tests. Since APIs have unique structures that are often proprietary, it is essential to recognize that SAST and SCA are not total solutions. Runtime protection and obfuscation might also be needed to effectively protect your application fully. But SAST and SCA are great starting points. Organizations can't just look for a one-size-fits-all assessment when building in a security approach. API security will involve significant overlap between different security areas, different parts of the system, development teams, and leadership stakeholders. The majority of API security risks will arise early on in the development process. We already know the importance of looping security into the development operations process, and with SAST and SCA, we are able to identify and protect against vulnerabilities early on during that process. The critical step is to take a holistic approach to API security, recognizing that security breaches can occur at any stage of the API development process, and security has to become integrated into each and every level as a result. SAST tools give developers real-time feedback as they code, helping them fix issues before they pass the code to the next phase of the SDLC. This prevents security-related issues from being considered an afterthought. SAST tools also provide graphical representations of the issues found from source to sink. These help you to navigate the code with greater ease and even understand the exact location of vulnerabilities and find them within your development process, enabling you to get easy guidance and fix the issues in the best place without really having to worry about it down the line or resulting in it getting forgotten or just missed altogether. Developers can also generally create reports that they need with these SAST tools, and the reports can be exported offline to track and monitor their progress, allowing teams to really stay akin of what exactly is going on within their applications, within their APIs, and get a good understanding of what needs to be changed, what needs to be improved in order to remediate some of those vulnerabilities. So with that said, it's really important that teams have to be cognizant of using SAST as part of an effective process. And so in order to do so, there's sort of 5 steps that teams can go through in order to use it appropriately. So the first step is to create the scanning infrastructure and deploy the tool. And this step involves handling licensing requirements, setting up access control and authorization, and procuring the resources that would be required. Then customizing to your exact needs, so fine-tuning the application to suit the needs of your organization, to suit the needs of the specific code base that you're scanning, depending on whether you're working on an application or an API. For example, setting up rules that help you to identify vulnerabilities you should be particularly concerned about, or forget about others that don't necessarily matter to your needs, or if you're planning to obfuscate down the line, you can deal with it that way. Obviously, prioritize and onboard applications. So once you have the tool set up how you like, onboard your applications, and then prioritize the high-risk applications first during scanning. And once this is done, you can then build it into your release cycle as you would expect. Then you need to analyze scan results, and this involves triaging the results of the scan, removing any false positives that might have come up, or as we mentioned before, issues that you might not be concerned about. And once this set of issues is finalized, tracking and then managing through the team to effectively remediate in a timely manner. And then obviously providing governance and training, so fully understanding exactly how the tools are being used if they're operating as you need them to, and then managing any security touch points throughout the rest of the development cycle. But what about SCA? So SCA actually provides a significant additional level of security, and it takes care of your code dependencies in a few key ways. Helps you to identify open source components, analyze applications, and identify their reliance on open source packages, either by direct dependence or transitive dependencies. And oftentimes we find a lot of vulnerabilities in third-party dependencies. In fact, recent research has shown that 80% of vulnerabilities are introduced via transitive dependencies. So this crucial to effectively mitigating risk. It can also help you to fully get compliance with any licensing risks that you might have. Obviously, we know APIs don't operate in a vacuum, and it's essential to identify the different open source libraries and licenses that are being used, which helps organizations to mitigate any legal risk that might be associated with using open source software. It also helps you to find any security vulnerabilities. So as we've discussed before, having vulnerabilities in your code, in your APIs, not a good thing. And so SCA tools can help you to correlate with vulnerability databases and point to security vulnerabilities within open source dependencies. And so with all that said, it's important that we now look at the Kiuwan, SAST, and SCA tools. So our tools are really designed to give you the best and most cutting edge approach to SAST and SCA. As we kind of walk through in that entire process, Kiuwan can help you create the scanning infrastructure and deploy the application. We have a lot of customization options to allow you to effectively use based on your specific needs. We work through a very specific action plan process that helps you to prioritize and manage any vulnerabilities that might show up in your code. And we also have governance and lifecycle control to allow you to get full grapple of your application and any dependencies and risks that might occur. And as we discussed too, all of those great SCA benefits. We also offer reporting and analysis, allowing you to produce a software bill of materials, getting a detailed list of the various dependencies in your code and the way that they're being used. And then you can use these reports to assess exposure to future security risk and share with any stakeholders to monitor and process this going forward. But with that all said, we'll now turn our words into action and demonstrate how you can scan your application code to enhance security, specifically looking at how we can use this functionality to protect our APIs. So with that said, we had one of our great sales engineers, Daniel Fonseca, put together a short demo to demonstrate how you can specifically use Kiuwan to remediate any vulnerabilities in your APIs.
So hello there. Thank you everyone for joining. Before we actually take a look on how to scan your APIs using Kiuwan, I would like to make a quick recap on the Kiuwan architecture. Remember that Kiuwan is a two-part platform in which on one side, we have the so-called Kiuwan local analyzer, which is basically an agent. It's a Java application that you can deploy at your developers level machines or in your servers as a service, if that's the case, or you can deploy it at your vendor's level. And what the local analyzer does is that it will perform the scan of the source code of your applications, and it will upload the results and only the results to the second part of Kiuwan, which is the portal engine, where you will see all the results of the scan. This is going to guarantee that the source code, your intellectual property, is never leaving your premises, is secured, and Kiuwan will only upload the results, and you don't have to upload the source code of your applications anywhere in the cloud. So let's take a look on how we can perform an analysis of your APIs and how to install the local analyzer and see the results in the portal engine. Whenever you will get access to a Kiuwan account, you will be provided and provisioned with a pair of credentials. From our official website, you will go to login page, and then you will have to enter your credentials. Once we log in, this is what we will see in the web console. We have the 5 components of Kiuwan. We have code security, code analysis, insights, lifecycle, and governance. So the first thing that you would like to do is to download the local analyzer. You click on your name on the top right corner, and then you click on download Kiuwan local analyzer. Basically, what this does is that it will just download a zip file to your machine, and then we can go ahead and open that file, unzip the file, and we will run the file that contains that information. So let me show you here. When I unzip the local analyzer, you will find this this file that you will execute, and it will run the graphical interface of the local analyzer. So while I do that, you see the local analyzer starting, and then I can just click on Let's Go. I will authenticate with the same credentials that I used in the web console. And when we are there, we are ready to scan our API. So as you can see here, the local analyzer has retrieved the information that I have in the web console. These are the applications that I have previously scanned in Kiuwan. You see, it brought all of them, the ones that I have here on the left. But now I will scan a new API. So I will just call this, I will give this a name, a new name, and I will tell Kiuwan where is the folder in which the source code file of my application is located. So let's go to here. Actually, let's find it here. Have some vulnerable APIs in here. So I will go ahead and scan this API, which I have called the Flights API. And I will call this, I will give a name to my application. Let's find the folder once again. And then I just tell Kiuwan that this is going to be a baseline analysis. I will and then I click on continue. And then I can select the model that I will be using for scanning this application. Basically, I have created a model which includes all the Python rules that the Kiuwan engine has. So I know that this API is developed in Python. So I will select this model for this particular application. I click on OK. I select that this is going to be a baseline analysis, and then I click on continue. Kiuwan is going to ask me that this application was not found. If I want to create it, I will click on yes. And then we just need to wait for the analysis to start running. So Kiuwan is asking me which are the modules I'm going to use in order to scan this API. So I'll use code security, code analysis, and insights. Click on analyze. You will see when Kiuwan will tell me that the results are ready, we will see here a green check. And then I will just, I will refresh in the browser to make sure that the results are visible in the web console. So please pay attention to this left panel. You will see here that a new application will be appearing afterwards when the scan will be completed. The name of the application is the Flights API, and we will see the results that Kiuwan will present after the scan. So it has been completed. We are ready to see the results. I could go ahead and click here, view results, and then this will take me to the browser. However, I'm using here an incognito session for the webinar purposes. But anyways, you can see here that I have my Flights API, code security. I will load all the analysis. And then you see here, it has the analysis that I just ran now, and the one that says that is the label that I have said before. So in the summary page, Kiuwan will break down all the vulnerabilities into a chart according to the severity of them. So we have 12 very high, 4 high, and then Kiuwan is giving a rating to my application, to my API. In this case, because I have 12 very high uncovered issues in security, Kiuwan is giving me 1 star, and it's telling me here on this chart the amount of hours that I will need to invest in order to reach a higher security rating. So here Kiuwan has identified the lines of code that my API has, the useful lines of code, how many files were scanned, and the amount of vulnerabilities. And in these histograms, he's telling me the top 10 vulnerabilities by type, and also which are the worst files. So in this case, this file is the worst one because it has the most vulnerabilities. And here there is a timeline. If I perform another scan, it will show me how over time the scan is performing. And of course, as I mentioned before, this API is developed in Python, and this is the only language that Kiuwan was able to detect, of course. Then if I want a detail on the vulnerabilities that were uncovered for this particular API, you will see that Kiuwan is also giving is breaking down this into different categories. So we have vulnerabilities which are related to injection, to misconfiguration, and to encryption. If we want more details on any of the vulnerabilities, Kiuwan is presenting this list in which, for instance, in this one, Kiuwan is detecting that we should be avoiding SQL code form with non-neutralized user input, because this is prone to SQL injection attacks. If I want more details on which files was this detected, I can just go ahead and click here. And here Kiuwan is showing me, okay, this was placed in this file, which is under this path. The files are named the same, but there are different files because you can see here that they are located under different paths. If you want more details on the lines of code in which this was uncovered or detected, you see here that in this particular file, we have the issue uncovered in line 157, 60, and 92. If I want more details on that, this is the line of code in which the vulnerability was uncovered. If I want more details and all the references to this particular vulnerability that was triggered by a rule of Kiuwan, can just click here on this question mark icon, and we have all the description and remediation, CWEs, normatives that are referenced for this. And well, we have as well a sample of how this violation appears and triggers the rule and how to fix it. Remember that this fixed code over here is not your code, but it's just a sample code that perhaps for your developers will mean something relevant, and they will understand how to fix the piece of code that was uncovered to be vulnerable. Then we have also the possibility to see the propagation path for these particular ones. So if I click here on the stack, you will see that this has a propagation path on these files, these other files. And then I can also take a look at the action plans, which are the things to do or the things to fix. So from all the things that were uncovered, you can pick some of them up, and then you can assign them to some of your developers. So here is telling Kiuwan that you need 20 hours, more or less. This is based on the experience of our developers. Kiuwan is telling you, okay, you need to spend 20 hours in order to resolve all of these vulnerabilities. And then you can, of course, go ahead and create an action plan for that. You can create the action plan from scratch, or you can use our what if tool. So the what if tool is presenting you with these couple of scenarios. The one, which is the current one that appears after running this particular baseline scan. And you can simulate with the what if tool. For instance, if you only have, I don't know, 10 hours for the next sprint in order to invest in security, you can say, okay, what happens if I invest 10 hours? What will happen? So Kiuwan will tell you, okay, according to that, if you only have 10 hours, you can have a new scenario after this simulation in which you can decrease to 0 or can remove all of the very high vulnerabilities, and then you can leave only 3 of them. So these are the things that were selected. This is the things to do, the task that you would like to assign to some of your developers. So you can go ahead and save this action plan, and we can just API flights API action plan. So we can put here whatever information, next sprint, things to do. And then you can assign it to some of your developers. This is the only user that I have in my account, so I'll assign it to myself. And then you can give also a deadline for this particular action plan. I will say, I will give a full month for this to be resolved. I click on save. When you save the action plan, you can go ahead and export these as well to different formats, PDF, CSV. If you have a Jira workspace, you can also integrate with Jira, and all of the items in the action plan will be exported to a Jira workspace in which you can, for instance, say that for every defect or vulnerability, a new ticket will be created. And if you use Jira among your developers, you can assign those tickets accordingly. Similar as in code security, we also have the analysis in code analysis. So you will see here, I will load the scan, the latest one. And Kiuwan is giving us here a different metrics, which are based on the 5 components of the ISO 25000 model, which are efficiency, maintainability, portability, reliability, and security. So this means that this is the quality part of Kiuwan. Code security is the SAST part, code analysis is the quality part. So in here, again, there is a summary which has different indicators, which are the risk index. The lower the value of the risk index, the better. Then the global indicator, in every of the metrics or the pillars of the model, you can select a target. By default, Kiuwan will assign a target of 90 in every of the metrics. And then the scan will tell you, okay, in each of these metrics, what I found. So the global indicator currently is 62, which is not bad. If we take into account that the target is 90, we see that nothing was found in the metrics of maintainability and security itself. But let's see here the results of the defects that were uncovered on this part. So most of them are from maintainability and security. There are a few of them. And therefore here, for instance, for security, it appears this this one again, the 2 files in which this was uncovered. And once again, we can see the lines of code in which this was detected. For maintainability, you see here that it's telling you, okay, avoid capturing generic exceptions. We can go and have the details on what is this about. If you need some information, you can click here. Remember, we will tell you all the description, code, reference, violation code, and a sample on how to fix it. So it's very similar as in the code security part. And then you can also, of course, have action plans which are related to quality. So I can create a new action plan with what if. The difference with code security is that in here, the simulation can be done by effort, how much time or hours you want to spend in each of the metrics or characteristics, or which is the target that you want to reach in each of them. So you can see that efficiency and portability are 100. So they're fine, but security we have 0 and maintainability 0.21. So perhaps you in security want to reach 70, let's say, or 90, sorry, 90. And therefore you want to simulate what you need to do in order to work on that. So afterwards you see that security will be fixed completely. And perhaps I also want to improve this one to 90 to see what happens. Let's simulate that one. So in that case, you see the risk index will be 0, which is ideal and optimal. And then it's telling me, okay, these are the things that you need to work in security and maintainability in order to reach that. I can save this action plan. And similarly as in code security, this plan can be assigned to some of your developers and exported to to Jira or any other format. Then let me see if I, so nothing was detected in the insights component, which means that this particular API is not using any third-party or open source component. So what I can do now, or what I would like to do, is to run another scan for another API that I have here that I will call the IDs validator API. So I can just go ahead and find the new folder. I click on open, and I will give the same label to this particular API. Once we are ready, we click on the continue button to start the scan. Once again, let's see how long it's going to take for this particular API. And now we will focus on the different vulnerabilities that will be uncovered here. And most likely this API is using some third-party components that will be detected by Kiuwan, and we can take a look at it. So while it runs, remember, on this left panel, you will see the applications that are being scanned by Kiuwan. You see this one appeared right now because I have run the scan and it's completed already. So I can just go and refresh my browser, and actually I can just click here and exit. I will go to the IDs validator API, load the results of the analysis, and you will see that this one is pretty much fine. It only has one very high and one normal vulnerability. Although I did something on purpose in here, and is that I didn't select the model, but I can take a look on what I have done. So every scan, every baseline analysis has a log, and I can take a look here, which was the model that I've been using on this particular application. Let me take a look here. So, okay. The model that I had been using, you can look at it in the application management. And if I click here, model, it was the CQM. So I made a mistake. I selected the model that I was not expecting to use. So what I will do is that I will open a new, once again, the local analyzer, and I will run the same scan, but I will be using a different model. I did this on purpose just to show you that according to the models, Kiuwan will present different results. And it happens because, as I mentioned before, I created a model with all the Python rules, and the CQM model includes Python rules, but not all of them. So let's take a look. I will look once again. So I will run another scan with the ID validator API, but this time I will click on the advanced component, and I will say I don't want to use this model, but the Python one that I created, because it includes all the Python rules, and I know this API is also developed in Python. Click on OK. I will give another baseline label, another baseline label, which would be API webinar using Python model. And let's take a look at it again. Let's analyze all of it once again. And let's pay attention here to the results. You will see here now that I will have a second analysis over here, and it will bring the label that I just set in the local analyzer. And we will see that different things were uncovered this time. So let's wait for the local analyzer to finish. It's almost done. The insights component is also running its scan. And then let's see. Okay, here's the things to be ready. we just refresh the page. And now we can go ahead and load all the analysis that we have done in this application. You will see here that I have 2 of them. Look, the previous one in which I used the CQM model and this one in which I use the Python model. If I go to the summary page, it will show me now that with the Python model, these things were uncovered, same as in the other one, but the difference most likely will be noticed in the code analysis component. So in here, we only have these 2 particular vulnerabilities. Let's take a look at them in detail. So Kiuwan is able to tell me that this particular API is vulnerable and prone to be a target for a denial of service attempt or attack. And also there is some issue with the cryptographic attacks on this particular API. If you want more details, there is the file in which was uncovered, the line of code that has the issue, same as in this other file. And also, as we did before, we have all the description of the problem, how to remediate the problem, some samples and references on how to fix the code. And then if we take a look at the code analysis component, here you will see the biggest difference. So if I load all the analysis, before with the CQM model, it gave me really few things uncovered, only in the maintainability and reliability and security, only 2 of them. But with the new model, with the new baseline analysis, we got more things, right? So we have now 97 maintainability, 10 reliability, 2 security, 1 efficiency. If I go to the defects page, we can see here that there are defects related to security, maintainability, telling me that there are too high number of statements in a method. If I want to know what happened there. So in 3 files and different lines here, this is a statement which is not okay. You can take a look at the details on that and then see how to fix it, how to make our APIs more secure. So as you could see, Kiuwan is not storing the source code files of your APIs anywhere, but only uploading the results and presenting the line of code in which some things were uncovered, right? And well, for this particular API, I'm sure that I have some third-party components. So you can see here that I'm using 29 components, which currently have no risk associated with it. But the Kiuwan in the insights component is showing you the obsolescence of every component. So it's telling me, for instance, here you are using this component. It's an open source component from Python, and it appears that it's out of date because Kiuwan is able to tell you, look, I can show you all the versions that this particular open source component has, and the one that you are using in your API is the one from 2019. It's the version 1.71, and you should be using the 2.3.0. So it's telling you, okay, this is the used version, this is the last version. There are 7 releases in between. So my advice is for you to upgrade and use the latest version of that component. Similarly, you can also check if any of these components is using some particular licenses. And in here, you can make sure that everything is properly licensed and you are using things which are, let's say, legal from a license perspective. So basically, this is what we have from the insights on the 3 components that we saw on this demo: code security, code analysis, and insights. You have the possibility to download or export the reports, for instance, of the vulnerabilities or the summary page. How you do that? In the case of the vulnerabilities, you will just click here on the stack icon, and you can export this file to a CSV format, or also export it to a threadfix format for JSON, to have a JSON format of the vulnerabilities that were uncovered. And also in the summary page, you can have a PDF. And if we download that, you will see how the summary appears. Let's take a look at it. So this is how the report appears for this particular application. And then also, if you would like to go to the code analysis, you have the same possibility. Can export a CSV. In the summary page, you will have also a report. Let's take a look at that. And then, well, this is how the reports look like. Same for insights. If you would like to have a look at the reports that you can have there. The components part, you can see here, you can export to a PDF, and it will just show you all the components that were detected in your application, your API. And that's it. So thank you very much for attending, and see you next time. Cheers.
So that was a very thorough demonstration of Kiuwan and how it can specifically protect your APIs. And that about does everything that we have for you today. And to wrap up quickly, here's a quick summary. Kiuwan SAST and SCA helps you to secure your applications, APIs, and reduce third-party dependencies. Works around your operations infrastructure, embedding security into your IDE, and provides direct, clear, and concurrent guidance on the actions that organizations can take to remediate vulnerabilities.
Thanks, everyone, for joining our webinar. If you have any additional questions, please email us at sales@kiuwan.com, as seen on the screen, and we will be happy to answer. A recording of this webinar will be uploaded to our website under webinars so that you can review at your leisure. Thank you again and have a great day.